Flow rate through a Venturi meter in a pump system by Izzuddin Najmi bin Anwar Halim, Muhammad Hazli bin Muhammad Noor, Muhammad Luqman bin Abdul Rahman, and Muhammad Nakiuddin bin Umar. Additional theory. Venturi meter is a flow measurement device which based on the principle of Bernoulli's equation. Inside the pipe, pressure difference is created by reducing the cross-sectional area of the flow passage. This difference in pressure is measured with the help of manometer and helps in determining rate of fluid flow or rather discharge from the pipeline. Venturi meter has a cylindrical entrance section, converging conical inlet, a cylindrical throat, and a diverging recovery cone. Component of Venturi meter. Cylindrical entrance section have the size of a pipe to which it is attached. The venturimeter should be preceded by a straight pipe of not less than 5 to 10 times the pipe diameter and free from fittings, misalignment, and other source of large-scale turbulence. Converging conical section takes place at an angle of 21 degrees plus minus 2 degrees. The velocity of fluid increases as it passes through the converging section and correspondingly the static pressure falls. Throat is a cylindrical section of minimum area. The velocity is maximum and the pressure is minimum. The throat diameter is usually between 1 per 2 to 1 per 4 of the inlet diameter. Length of the throat equals its diameter. Diverging section is a section in which there is a change of stream area back to the entrance area. The recovery of kinetic energy by its conversion to pressure energy is nearly complete, and so the overall pressure loss is small. To accomplish a maximum recovery of kinetic energy, the diffuser section is made with an included angle of 5 degree to 7 degree. This angle has to be kept less so that the flowing fluid has less tendency to separate out from the boundary of the section. The objective of the experiment is to observe the volume flow rate through the venturimeter, to discuss the function of venturimeter, and to learn how to operate venturimeter in pump system. Procedure. First, switch on the main switch and motor drive isolator. As a reminder, before operating the system, make sure the delivery valve is in fully open condition and inlet valve in fully closed to make sure the pump is completely filled with water before running the system. Next, press start button to start the pump motor. Then increase the speed to 1000 rpm. Let the inlet valve to be open at full opening. Increase the speed until it reaches 3000 rpm. Use the bleed line to bleed the bubbles trap. When the system was stable, record the reading of delta P1 and P2. As shown in the digital pressure display, P2 is not exactly at the value of P2 that are needed, which is negative 0.89. Thus, the action of bleeding the bubble strap in the pressure gauge is necessary. Repeat the step needed to obtain the other 6 sets of data. The value of P2 need to be varied at every deviation of 0.05 bar by decreasing the opening of pump inlet. To end the test, slowly reduce the speed, fully close the inlet, and switch off the pump motor and the main power supply. From the experiment, we could observe that the pump inlet valve needed to twist a lot of the time, and the turn of the pump inlet valve needed to be precise to get the exact amount of flow rate for the pump speed to reach from 1000 rpm to 3000 rpm. We also observe the need to use the bleed line as to bleed the bubble that are forming in the tube that can alter with the result for this experiment. And during this experiment, loud sound can be heard as the pump speed increases. These are the calculation for this experiment. From the graph plotted, we can see that as P2 decreases, P1 will decrease. Question: the inlet pressure of the pump P2 shows a negative value. What does this mean and why this is happen? This phenomena happen due to the Venturi effect, which states that in a situation where there are constant mechanical energy, the velocity of a fluid moving through a narrow area will increase and its static pressure will decrease. The effect utilizes both the principle of continuity as well as the principle of conservation of mechanical energy. Conclusion: from the experiment, we can now deeply understand how to operate the system properly and achieve the result needed. And during the experiment, we encounter a few problems regarding the form of bubble in the tube which may interrupt with the result of the experiment. Nevertheless, by using the bleed line to remove the bubble help to achieve a more accurate result. Our suggestion for the experiment is to have the water dyed in different color, especially in a dark one so that it is easier to spot the form of a bubble. These are some references for this experiment. That's all from us. Thank you.